Okay, so number one is telling you to determine whether the following, which is this chart right here, is a probability distribution, and if it isn't, then to identify the requirement that it isn't meeting for a probability distribution. So in order for a probability distribution to work, all of your P of x's, which are your probabilities, have to sum to 1. So this is what this means right here. So if it is a probability distribution, then all of your P of x's are going to equal to 1. So I'm just going to add them up and see if they do. So 0.037 plus 0.200 plus 0.444 plus 0.296. Okay, so once I added all of these up, they sum to 0.977. So notice how this is not the same thing as 1. So no, this is not a probability distribution, because the sum of the P of x's isn't 1. And then if it wants you to find the mean for it, this is going to be the formula for it. It's the sum of all the x's times P of x's. So here's your x row, and here's your P of x row. So, but you're going to have a row which multiplies them. So let's just call this row x times P of x. Okay, and then once you have this, you could just multiply straight across. So 0 times 0.26, that's just going to equal 0. 1 times 0.11 is 0.11. And then 2 times 0.16, it's going to be 0.32. And then 3 times 0.05, it's going to be 0.15. And then 4 times 0.42, that's going to equal 1.68. So this is completing this portion of it, but this right here, this means that you're going to have to add all of your x times P of x's up. So you're going to do 0 plus 0.11 plus 0.32 plus 0.15 plus 1.68. And that is 2.26. And so your mean is 2.26. You just multiply x times P of x for each one, and then once you get them, you just add them, and that's how you get your answer. Okay, and now this one is telling you that a contractor is considering to sell that promises a profit of $26,000 with a probability of 0.7, or a loss of $8,000 with a probability of 0.3. And it wants you to find the expected profit. And expected profit is the same thing as finding your mean, because you have an x and then you have a P of x, and then you're multiplying those P of the and it's the same thing, because you're you have an x, you have a p of x, and then you're going to be multiplying them and adding them together, and that gives you your answer. So the first thing that you have to do is identify what your x is. So x is usually outcomes, and in this case, it's money, actually. In this case, it's money because they're saying that he can have a profit of 26,000 or a loss of 8,000. And since that's a loss, it's going to be negative. So his outcomes are either that he's going to gain this much or lose this much. So that 26,000 is going to go right here. Okay, so it's positive because there's a chance that he can gain it, but there's also the probability that he loses $8,000. So since that's a loss, that's considered negative. And then, so these are your x's, and then you have your p of x's. And p of x's means probability of x. So probability of getting $26,000. And it tells you that there's a probability of 0.7. But then it says that the probability that he loses $8,000 is 0.3. And then if you add these up, notice how they add up to 1. That's how you know that they actually are a probability distribution. So now that you have your x and your p of x's, you have to make a row where you multiply them. Okay. So you multiply them at 26,000 times 0.7 is this much. And then you just multiply across like in the last problem. So now negative 8,000 . And whenever you're multiplying a negative in these, your x times p of x, it's going to be negative. So, and whenever you have a positive, whenever you have two positives, you're going to end up with a positive. But if there's one negative, then your p of x times p of x is going to be negative too. So now that you have all of them, then you just add them together. So 18,200 plus negative 2,400. And that adds up to 15,800. So notice how it's positive. So that means that you're expected to still earn this much. So your answer is B. Okay, so this question is asking you to find out whether it is a binomial or if it isn't. So in order for it to be a binomial, it has to have only two outcomes, which are referred to as a success or a failure. There's a fixed number of trials, like there is a fixed number of trials, and then the events are all independent from each other. And so they're telling you that you're choosing 5 marbles. They tell you that 20 are purple, 12 are red, 8 are green, and that they're with replacement. So then it wants you to identify based on this information if it is a binomial. And they're telling you that you are choosing 5 marbles, so your n is 5. That is a fixed number. So it meets that requirement. but then it's telling you that there's 20 purple, 12 red, and 8 green. And the thing with that is that it's telling you that you have these colors, but it's not telling you what's a success and what's a failure. It's not saying how many blues are there, how many not blues are there. I feel like that would be an example of a success. So it doesn't really have, and it has 3 outcomes too. So it doesn't have a success or a failure identified on the problem. So it doesn't fit that requirement. But then it tells you that it is with replacement, and whenever with replacement, that means like if you pick out one marble, you put it back, so the probability doesn't change, so that the marbles, their events are independent, but it's still not meeting that success or failure requirement. So because of that, it would have to not be a binomial, and it's D. Number 12 is telling you to find the mean for a binomial distribution. And for a binomial distribution, the formula for the mean is n times p. And then notice how that's what they gave you right here, n times p. So you just do 1665, which is your n, times 0.57. And after multiplying them, I got that my mean is 949.05. So I got this answer, but it looks like they're rounding it to the first decimal place, so this eventually converts to 949.1. And that is D. And then number 14 is telling you that according to a survey, 22% of students work full-time. And it wants you to find the mean for the number of students who work full-time if they had a sample size of 16 students. And so this is a binomial distribution, and you can identify that because it gives you a rate of success. It has 22. So you either have students who work full-time, which is your success, or you either have students who do not work time, which is your failure. So it has your success, which in binomials is referred to as P. And then you have your fixed number of trials or fixed number of people, and it tells you that it's of a size of 16. And so the mean for a binomial is n times p. So you just multiply these. So 16 times 0.22 and that is 3.52, but if you round it, it's just 3.5. Okay, so number 18 wants to find the probability that you have a value that is greater than 5. So 5 is right here, and you want the probability that it's greater than 5, but your distribution ends at 8, so it also can't be more than 8. So you want to find the area of this shaded region right here. And area is length times width. So you want to find the length and the width for this shaded area. So you want to find the length of a number being from 5 or more. But it can't be more than 8 because that's where the distribution ends. So to find the length in between there, you take your 8 minus 5, and that is 3. So that tells you that there are 3 numbers right there. So your length is 3, and now you have to multiply it with your width. And your width is always going to be what is over here. If they didn't give it to you, then it's going to be 1 over b minus a. But since they did, you're just going to multiply by 0.125. And 3 times 125 is 0.375. And that is C. And then number 20 is telling you to find the area of this shaded region right here. And notice how it's a normal distribution with the z-scores. And notice how the area ends at 1.13. So you're going to be using this z-score to find your area. So you're going to be using the chart. And the way that the chart works, and so you're going to be using the z-score chart. And then first identify what type of z-score you're working with. Is it positive or is it negative? So it's not negative, because if it were negative, if it was negative 1.13, the shading would have stopped right here. But notice how it starts at positive 1.13. So since it's positive, you're going to be using the positive z-score chart. And it was of 1.13. So now you look for 1. Here's 1. So you're going to be, answer's going to be on this row somewhere. It was, but it was 1.13. So here's 1.10, but here's 1.11, 1.12, 1.13. So this right here is where the 1.1 and the 0.03, and if you add those together, you get 1.13. So they both meet there, so your area is 0.8708. Oh, and that's this one right here. 21's a bit different. Notice in the other problem, it only worked on area shaded to the left, but this one's working with area in between. So this basically wants you to find the area for the z-score being between 0.92, well, a negative and a positive 0.92. So P92. So in order, I just notated it like this. So you're gonna have to find the area for both of these z-scores right here. So negative 0.92, that tells you that you're gonna be using a negative chart. Negative 0.9 is on this row. You want negative 0.92. So here's the 2. Okay. So the area for negative 0.92 is 0.1788. And now the positive one, 0.92. Oh, and then it's positive, so you're working on the positive chart, 0.9. Okay, so 0.92 is right here. This is where they both meet, so the area for that one is 0.8212. So whenever you have an in-between probability for this type of area, you're gonna use the bigger number first, 8212, and you're gonna subtract the smaller number, because you want that in-between area, and this is working with what's on the left. So okay, and after subtracting, I got that my answer was 0.6424. And that is right there. But yeah, whenever they want an in-between probability and they give you the z-scores, find the z-scores for both of them, convert them into areas, and then you're gonna take the bigger area and then subtract the smaller area, and that's gonna give you that in-between area. Okay, So notice how this one's, it tells you it's a standard normal variable and it has a z-score and probability, so you know that you're going to be using the chart for this one still. So it wants you to find the probability that z is greater than a z-score of negative 1.82. But the way that the chart works is that it uses area on the left. So like less than, if it were less than, you could just look at it on the chart and that would be it. But if it's greater than, there's 2 steps to it. And I would say that the first one is to find the area of the z-score that they gave you. So it tells you that negative 1.82 is your z-score. So convert that to an area. It's negative, so negative 1.8, negative 1.82, yeah, it's right here. So this is the area for it, 0.0344. And now you're gonna do 1 minus that. 1 minus that same area. Because since the chart only works to the left, you're gonna have to use the complement. So 1 minus 0.0344 is, it gave me 9656. And that is B. 17 is basically asking you to explain the empirical rule. And this is also called the 83, 95, and the 99.7 rule. So when you're working with the standard normal distribution, let's say that the mean is right here. Let's say that this has a z-score -1, which is -1 standard deviation, -2 standard deviations, and then -3 standard deviations, and then the rest just goes on. And then there's 1 standard deviation above, 2 standard deviations above, and then 3 standard deviations above, and then it goes on again. So what the empirical rule states, this is completely symmetrical right here, so there's 50% of the area left of the mean, 50% of it to the right. And so it states that 68% of the area is within 1 standard deviation. And then it says that 95%, including that 68, is 95% of your area. And then it says that this 99.7, this means that your data is, that 99% of your area is within 3 standard deviations. So this is why it's called the 68, 95, 99.7 rule, because there's 68%, the majority of it, when you think about it, within 1 standard deviation, and that makes sense because look how much data is in here. And then including that 68, 95% of your data is within 2 standard deviations, and then 99.7 is within 3. And then this other 0.3%, it's based on outliers. Okay, so it's telling you that for 24 to assume that it's a normal distribution with a mean of 15.2 and a standard deviation of 0.9. So I'm just going to draw this out. And for a standard normal distribution, your mean always goes in the middle, sorry. Your mean is in the middle, and it has a z-score of 0. And so it wants you to find the probability that x is greater than 15.2. So the way that the standard normal distribution works is that it's completely symmetrical. So once you split it down the middle, it's 50-50. There's 50% of your area going this way and 50% of your area going that way. And if you add them together, that'll equal 100%, which is what your total area should be. So since 15.2 is what splits your data down the middle, the probability that you're going to get something greater than that is 50%. Or if you want to have that as a decimal, 0.500. The same goes if they asked you if it was less than 15.2. It would still be 50 because 15.2 splits it down the middle. This is just a quick overview for question number 6, which goes over discrete and continuous data. So with discrete data, it can be counted and it has gaps in it, but continuous data, you measure it instead of counting it. It could go on forever, like pi, it never ends, and it has no gaps, and that's why it keeps continuing. So to give an example of this gap, I'm just going to use these two. There are 2 pens here. I can't have 2.5 pens. I have a gap. I either have 1 pen, 2 pens. I can't have a 2.5 or a 2.75 of a pen. The same goes for number of whiteboards in a room. You can either have 1 whiteboard or you can have like 0 whiteboards. And then for continuous data, since it's measured, it can be something like age, a height, or time. Let's say, because right now, let's say I'm 19 right now, but I'm getting older as the seconds progress, even right now. Like, let's say I'm 19 right now, but I'm getting older as I speak, so it's keeping on continuing. And then height, for example, I mean, you can say that. And then height, since it's also measured, this is also continuous. Because you can be like, I'm 5 feet, when in reality you're like 5 feet, but you're this many inches, this many centimeters, this many millimeters, and it keeps on continuing is the thing. And then same for time and age. You have your hours, your minutes, but then you have your milliseconds, and then it just keeps on continuing. And it keeps on going on forever. Okay, so number 15 is telling that there's like a distribution of test scores, and that it's a normal distribution, which means that it's going to be using that bell curve. And then it tells you that it has a mean of 50 and a standard deviation of 6. So your mean, and then in a normal distribution, your mean always goes in the middle. So this 50 is going to go right here. And then it tells you that you have a standard deviation of 6. So I'm just going to fill in. Okay. So your mean always goes in the middle, and then it tells you that you're going to have a standard deviation of 6. So in order to find out, in order to add 1 standard deviation, so to find what comes right of your mean, you have to do your mean plus 1 standard deviation, and your standard deviation is 6. So 50 plus 6 is 56. And in order to find what's 2 standard deviations to right, you add 2 standard deviations to your mean. So your mean plus 2s, 2 times 6 is 12. So 50 plus 12 is 62. And then your mean plus 3 standard deviations. 50 plus 18 is going to be 68. So this is for what's right of the mean, but for what's left, now you're going to be subtracting your standard deviations. So 50 minus 6 is 44. And then now you're going to be doing your mean minus 2 standard deviations. So 50 minus 12. And that is 38. And now to find what's 3 standard deviations to the left, you're going to subtract 3 standard deviations. So 50 minus 18 is 32. So this is your mean and your standard deviations added or subtracted from each other. But if I wanted to convert them into a z-score, then but if you want to convert them into a z-score, your mean, since this is the mean right off the bat, it has a z-score of 0. And your z-scores are going to be how many standard deviations a number is either above or below from the mean. So 56 is exactly 1 standard deviation above your mean. So it has a z-score of 1 because it's only 1 standard deviation above. But 62 is 2 standard deviations above. So it has a z-score of 2. And then 68, it's 3 standard deviations above, so it has a z-score of 3. And then, so these are for the positive z-scores, well these, and then so for the negatives, 44 is 1 z-score below the mean, so it would be negative. And then 38 is 2 standard deviations below the mean again, so since it's below, it's negative. And then 32, that's 3 standard deviations below, so that would be negative 3. So if you standardize it, your mean is automatically 0,